In this third module on data science, we're going to talk about how to analyze data. So once the data is read into Python, the first step might be to just analyze the data with summary statistics, especially if the data set is large. So they include things like count, mean, standard deviation, maximum, minimum, quartile information. Try to identify any outliers. Okay, so first of all, we're just going to generate some sample data here. I'll import NumPy. Just set the random seed 0, just so we get the same values each time. You can delete that if you'd like to get different values. And then I'm just going to have a random uniform distribution, a normal distribution with mean 1 and standard deviation 1 with n 1000 data points. And I'll stack those together and I'll save the data file. Okay, so here is the data file. Let me just go to the desktop. We'll just look at some of the files that are created here. Okay, so I have 03 and this is data.csv, and I can just open it up here and I'll see that it just created a CSV comma separated value file. The data distribution, you can look at this. I'm going to talk more about how to visualize data, but I'll just have a histogram and then just show that. Okay, I'll need the matplotlib inline just for the Jupyter Notebook, and that shows the data distribution, the uniform distribution, and the normal distribution centered around 1. Okay, let's do some data analysis with NumPy. So you can, when you import NumPy, you can load that data file, and I'm going to skip rows, just one, which is the header, and then look at the dimensions. And I'll use np.size, and I look at the number of rows and the number of columns. And then I look at the average as well, and I do axis 0 to look at the average of everything in a certain column. Okay, the standard deviation as well, and then the median. Alright, so when I run this, I can see the average of each of those columns. If I switch this to axis equals 1, then it's going to show me the average of all the rows instead. Okay, you notice I didn't say axis equals. It's just implied if it's a second argument. In there you can just leave that out, or you can put it in if you'd like to. Alright, so average, standard deviation, and median values. Alright, so let's try this. Calculate the mean, standard deviation, and median now of x times y. So I'm going to make a new variable z, and let's just print z just to look at it. Okay, so there are the values. And then let's go ahead and calculate the mean, standard deviation, and the median. There's the mean. Let's do the standard deviation. And we'll also do the median. Okay, then the final thing that asks us is to do the skew of x times y. So what is the skew? I'm just going to plot a histogram just to be able to show this. I'll have 30 different bins, and let's do label equals z, and I'll do plot.show. So it's skewed to the left, and so it's a measure of how much it's not a normal distribution. But we want this as a metric, and so we'll go to this function here. There are many functions in SciPy and in NumPy for statistics, and many of these have an example. This one does not, but we're going to get scipy.stats.skew, and axis by default is 0, and so let's just go ahead and just copy this, and then we'll put that into our notebook. So the first thing we need to do is from scipy.stats. If we just want to import just skew, we could do it like this, and then all we have to do is skew and then our z value. Alright, let me print it out just so we can see the skew value. That's going to just add one more number here, which is about 1.2. Okay, so it says it's skewed to the left, and if you look at this, okay, so let's see, a skew value greater than 0 means there's more weight in the left tail of the distribution. So we definitely saw that it was greater than 0, and this was definitely a positive value. You could see that from the plot as well. Okay, so summary statistics, they can tell you things, mean, standard deviation, the skew, and many other things. Okay, data analysis with pandas. Pandas is especially nice because we can do things with it like the describe function of a data frame. So when I import pandas and I read the CSV and then I just describe it, then it's going to print out a table for me. Okay, I have time, x, y, and I have count, mean, standard deviation, min, 25%, 50%, 75, and the max. Okay, and this, some of these, like the min all the way up to max with the quartile information, that might be better with plots to be able to show that. There's a few that we'll talk about in the next lesson on visualizing our data. Okay, so let's do the temperature control lab. You'll need to plug this into the USB for communication to your computer. And then on this side, the white cable, plug it into the power outlet. And we're going to run this for 2 minutes. We're going to just create a file and then we're going to analyze it. Okay, so all of this is already written there for you. And go ahead and just run it for 2 minutes, and it's going to create this file similar to what we've already done in creating a CSV file. Okay, if the file is not found, then you can just import it here instead. Okay, but I'm going to go ahead and just run this, and then we'll talk about the next section as well, just as this is running and collecting some data. It's going to shift down on us every 5 seconds. But we can also use requests to download a sample of TC Lab data for analysis. Okay, so this is just another way to retrieve data. I'm going to import requests, import OS. Here's my URL. It's a different data file than the one up above. And I'll create a new request for getting the URL. And then I'll write the response, okay? This is going to be r.content. Okay, so this is going to be what was read from the request, and then as I write that as a CSV file. Okay, and then let's just print the current working directory. And after these 2 minutes are done, then I can run this one as well. The very final thing that we're going to do is read these 2 files. The one that's being generated right now, it's shifting my screen down every 5 seconds. And this one that I'm going to read from a URL and be able to copy that data file onto my computer. Okay, but let's go ahead and just type these out just as this is finishing. We want to load these, and so I'm just going to say data1 equals and pd read CSV. And I'll just copy this file name here, and then let's do data2 as well, and that is going to be TC Lab 2. Alright, and then I can do data1, and then I'll describe the data, and then data2 describe. Now if you put it at the very last of the commands, it'll go ahead and just print it for you, and it'll format it really nice as well. Or you can do print, and then there's also a display function that you can use in IPython Notebook, but I'll just stick with print for now. Okay, let's just see how it's doing, and it just finished. Okay, so that first data file is there. This one is going to be 03 TC Lab 1.csv, and you can see all of the values up to 119 for 120 data points there. All right, and then I'm going to go ahead and read this one as well. And it just retrieved it right here. I'll double click it and just open it with Excel. Okay, so you can see the data right here. All right, now let's run our data analysis and just be able to print the summary statistics for each of them. So this is data set 1. It had 120 samples in there. You can see the mean, standard deviation, and then the quartile information. And then here's the one, the other one that I read in, that had a 601 data points, so it ran for 10 minutes. And you can see the different statistic information there in in that summary. You just leave this off. This is just what I'm talking about with just a little bit nicer table that it prints out for you with the very last cell. So you could do that with 2 of these. Okay, I'll insert a cell below, and let's go ahead and delete this one. Okay, so here are the 2 tables again. Okay, so just to summarize what we've learned here, when we import data, we often want to just take a quick look at it, not necessarily even creating a graph, although that's nice, but just some summary statistics. We learned how to do that with NumPy, with and some other functions like SciPy. We can also do that with pandas as well, with the very nice describe function once it's in a data frame format. And then we ran the TC Lab for 120 seconds and compared it to some other data that was online and with some summary statistics.